Okay, so welcome to this video for Chem 161 and on some Chapter 1 content. We'll be addressing the classification of matter. So to start, we'll make a little chart. We'll have matter at the top of the chart. And we know that all matter can be grouped into two different major classes. So the first is a major class called pure substances. And the other is going to be mixtures. So pure substances can be further divided into two different classes of materials. And we can have elements and pure substances can also give us compounds. Okay. Mixtures, on the other hand, we can divide mixtures into homogeneous mixtures. Okay, so homogeneous mixtures are those that are uniform in most of their properties versus heterogeneous mixtures are not uniform in their properties. So all classes of matter, all types of matter, can fall into two different categories, one called a pure substance or something called a mixture. And pure substances can be made up of either elements or compounds, versus mixtures, which are classified according to their uniformity. Those that are uniform in their properties are called homogeneous mixtures, and those that are not uniform in their properties are called heterogeneous mixtures. So, elements are typically found on the periodic table. And elements are a substance that cannot be separated into simpler substances by a chemical process. Okay, so these cannot be separated into simpler substances by a chemical process. Some examples, again, those listed on the periodic table are things like carbon, which, as you may have seen on the periodic table, is given capital C. Other examples would be oxygen, given symbol capital O. Chlorine, given symbol capital C, lowercase l, etc. Compounds, again, a class of pure substance. These are composed of two or more elements that have been chemically bonded together. These compounds can be separated but will require a chemical reaction to separate the bonded elements from each other to make the simpler materials and rewind the material back to the two or more elemental form after such a chemical reaction. So an example of this might be, for example, sodium chloride which you can tell by the formula, capital N lowercase a, capital C lowercase l, sodium chloride, indicates that both sodium and the ion of chlorine have been bonded together. So a chemical reaction will be required to separate these two ions from one another and turn them into their elemental form. Okay, heterogeneous mixtures, as we said a moment ago, were uniform throughout the entirety of the sample. And what we'll say is can not be easily separated. We'll see heterogeneous mixtures can be easily separated. So, to touch on the difference and the nuance of easy separation, consider an example of, say, your favorite chicken noodle soup. We know that chicken noodle soup consists of broth, which will have things like water and salt, perhaps nutrients from the chicken or from any of the vegetables. And we can expect there might be some noodles. Okay, here's my bad drawing of some noodles. And perhaps some chunks of carrot and chicken, etc. This chicken noodle soup would be considered a heterogeneous mixture, given that we could easily separate carrots, chicken, noodles from the broth. Now the broth, once free of all of the larger segments of material, noodles, chicken, carrots, might be regarded as being uniform, meaning it would be mostly the same color, perhaps the same consistency, nothing would settle over time, and so we would call the broth homogeneous, therefore. And that would be a homogeneous mixture. So you can see here that heterogeneous mixtures can have homogeneous components in them. And some of those components, like salt, sodium chloride, are a compound, a class of pure substance. And so this is how we classify matter per our definitions from your chapter 1.